So let me record that. Okay, good. So there's a couple of kinds of sequences that we sometimes come across. Let me give you an example. 2, 5, 8, 11, and so on. Well, I'm noticing here a pattern that to get from one term to the next, you add 3.
Okay.
So we call this a linear sequence. There's another kind where you might multiply. Let me put 3, 9, 27, 81, etc. Here we're multiplying by 3 to get from one term to the next. When you see this, this is called the geometric sequence. So you have to kind of notice the pattern. Okay, so let me come to this one. It says, consider the sequence defined by this recursive formula. It says a sub n equals 2 times a sub n minus 1 plus a n minus 2. Now, these subscripts, when you see capital N is which term you're referring to. Let me give you an example. In this sequence here, I might call the 2 n equal 1 because that's the first term. 5 would be n equal 2 because that's the second term. So this n is kind of counting what position you're sitting in the sequence. Now, when you see the word recursive means you can use previous results to calculate a new result. So we're going to build this kind of starting with the first term. That's going to allow us to generate the second term and so on. This is different than what's called a closed form. A closed form would let you calculate the 20th term immediately. If you were going to use the recursive method to calculate the 20th term, you would first need to calculate the 19th term and the 18th term and so on. So recursive means...
I think that's a big thing I was having as well, is there's some of them where I would feel like I feel like there's a way you can jump to A50 or and then some of them I'm like, do I have to work out the other 20 or is there another formula?
Right. That's right. And usually if you see something like A50, the problem's not asking you to calculate all 49 previous terms. Usually there's going to be a shortcut to get directly to A sub 50. And we call that the closed form way of generating the terms in the sequence. All right, well, for this one, I'm noticing it says list the next 4 terms of the sequence. So they gave us a sub 1. They told us that's 1. They gave us a sub 2. They told us that's 1. So, of course, next we want to calculate a sub 3. We don't know a sub 3. Well, that means the third term. So really they're asking us, what is a sub 3? That's what we're trying to figure out. So n is 3 in our example. It's the third term we're trying to figure out. Well, if n is 3, this n minus 1 subscript here would be 3 subtract 1, which is 2. So this would be a sub 2. And am I recording? Yeah, I'm recording. Yeah, so Bob, you can go back later and watch this recording, of course, if you want.
Okay.
How about this subscript right here? It's n sub 2, n minus 2. Well, our n is 3, so 3 subtract 2 is 1. Well, now I can plug in some numbers for this because we know a sub 2, that was given to us in the problem as the value 1. We can also drop in a sub 1. That was given to us, happens to also be the number 1. Now I can just work this out. This is 2 plus 1, which is 3. So a sub 3, we just figured out, is the number 3.
Okay.
So I'm going to put a 3 here. All right, so let's go ahead. So this is what we just found out was a sub 3 is the number 3. Let's go and do maybe another one, a sub 4. Well, I'm going to use the same recursive formula. Now that I know a sub 3, it's going to allow me to calculate a sub 4. So let's write the pattern for a sub 4. For a sub 4, it's going to be 2 times Now I got to take 4 minus 1 for the subscript. That's going to be 3. Plus this subscript n minus 2. Actually, let me write it out. Maybe it's better if I write it out. This way it's easier to see. Let me, hold on a second. Let me redo this. So I want to figure out a sub 4, and I'm going to write the pattern again so we have it. So the pattern is a sub n equals 2 times a to the n minus sub n minus 1 plus a n minus 2. All right, well, for us, they want a sub 4. Well, if n is 4, this subscript here is going to be...
It's going to be n3.
And if n is 4, this subscript is going to be...
So a2?
Yep. So now let me just plug in the numbers here. A sub 3 we figured out a second ago. That's the number 3. A sub 2 we know that was the number 1. So this is going to be 6 plus 1, which is 7. So that's the next number in the sequence. And this is how you can keep building these values. Can I let you try one? You want to try one? How about if we do?
Sure, I'll go to the next one.
Yeah.
Okay.
I'm gonna write down the pattern for you, and then you fill in. So let me write up here. A sub n equals 2 times a minus 1 plus a n minus 2, and now we're trying to figure out a sub 5.
Okay, so it would be a sub n equals 2 times, so we're on a sub 5, so sub 4, which would be 7. So 2 times 7 plus 3.
You got it.
So 14 plus 3, 17.
You got it. Nice. Yep, exactly. So 17.
Okay.
And you could continue this pattern. Now they're asking for a sub 8. At part B, you notice it says find a sub 8. Well, you'd have to do this manually. You'll be finding a sub 6, then you can calculate a sub 7, and then you can calculate a sub 8.
Okay. That's easy day on that one.
All right. Let me see. I think you all said number 5. I think number 5 is going to be very similar.
Let me see here. I think then knowing that, I think I'm good with number 5. It looks like exactly the same one.
Very similar. They just changed the numbers a little bit.
So let's see. That makes sense. My only question would be then on the first one, when I would plug in the for the a n minus 2, that's going to be -1, so that's going to be okay. So it'd be just what, -3, and then we'll go from there. And
Should we do one real quick?
Sure, I'll just do the first one, I guess.
Let's do the first one. So they're giving us a sub 1, a sub 2. So the next term they're asking us for is a sub 3. So a sub 1, a sub n on this one is 2 times a sub n minus 1 minus 3 times a n minus 2. All right, and they're asking us for a sub 3. All right, well, this subscript here, n subtract 1, is going to be 3 subtract 1, which is a sub 2. And back here, this subscript is n minus 2, but our n is 3, so that's going to be 3 minus 2, so that's going to be a sub 1. So let's plug in the numbers they gave us. They told us a sub 2 is a 1, and they told us a sub 1 is a -1. Now, this is a little tricky. We got to be careful here. For this expression to work this out, there's something called order of operations. And that says you should do multiplications first before you do any additions or subtractions. So let me do this multiplication. 2 times 1 is 2. And back here, I'm going to do this multiplication. 3 times -1 is a -3. And there's a subtraction. And of course, you could do this on a calculator if you want. But when you subtract a negative number, it actually flips to be an addition. So when you subtract a negative, it flips to be addition. So this is going to be 2 plus 3, so a 5. So the answer is 5. Is that okay for that one?
Got it. Yep, I think I'm good. And then from there, we just repeat the pattern again.
Yep.
Okay, perfect. Thank you.
Good. All right.
I think number 12 was next.
Well, let's go look at that one. All right.
So this one, I think I understood most. Let me look at my thing again. So I got the explicit formulas always mess me up. I think I'm overthinking them, and I think I'm about to discover. So I got the 8 plus, and then I didn't know what to put in for that third value.
All right. So let's talk. I'm noticing they say linear. It's a linear pattern. A linear pattern means to get from one term to the next, you're adding some number or subtracting some number. So if you notice in our textbook, it's going to give you the pattern. It says for the linear model, it's going to be P sub n equals P sub 0 plus D times n. P sub 0 just means the first term in the sequence.
Okay, I'm glad you said that one, because in this one I figured out, right, P sub 0 sub 0. So when I was pulling the linear formula, so I was like, okay, that's 8, that makes sense. But exactly in other ones, when I would see like a P sub 1 or a P sub whatever the first number was, I didn't understand why that always meant that one. Okay, so that just means the first.
So let me explain a little bit about the terminology here, which is confusing.
Sure.
When you write out some terms, let me give you an example. I'm going to use 3, 7, 11, 15, etc. I'm noticing these are adding 4 as I go from one term to the next. That 4 we call the common difference. It's the number you add to get to the next term. Well, that's what the D represents. D is the number 4 in this example. Now, the way you label these is I'm going to call this first term P sub 0. The second term is P sub 1. The third term is P sub 2, and so on. So in some sequences like this, they sometimes label the first value as P sub 0. You might say, shouldn't they label it as P sub 1 because it's the first term? Yes, it's confusing. Sometimes they label it as starting with a 0. Other times they label things starting with a 1. So in this linear equation they're giving us, the first term is starting with a 0, so P sub 0. So let's do a quick example here. Let's say I wanted to know, actually, let's go back to this example. I just wanted to explain the P sub 0 business. All right. So now what we have to figure out is how to write the explicit formula. Once we know that, we'll be able to figure out P sub 50. Well, let me start out with the formula, right? So let me write the formula again. It says P sub n equals P sub 0 plus D times n. Well, I'm noticing they're telling me that P sub 10 is 38. And I know P sub 0 is 8. What we don't know in this formula is little d. So we have to somehow find little d, the common difference. Okay. Let's plug into this equation. And I'm going to let's do P sub 10. So P sub 10 is P sub 0 plus D times 10. Right? Because in our example, N equals 10. N is the subscript on the P. So Rn is 10, so I'm dropping in a 10. We know P sub 10, they gave that to us as 38. We know P sub 0, they gave us that as 8. Now I can try to solve this equation. Let me start out
Got it.
subtracting 8 from both sides. What I'm trying to do here is get that D all by itself on the right-hand side of the equation. So let me get rid of that 8 in front. The way I can get rid of that 8 is subtract 8 from both sides. Because this 8 subtract 8 will cancel each other out. On the left side, I have 38 subtract 8, so that's 30. And that's equal to D times 10. One more step, because I want to get D by itself. Well, right now, D is being multiplied by 10. I want to cancel out a multiplication, so I use division. So I'm going to divide both sides by 10. On the right side, when you multiply by 10 and divide by 10, those are like opposite operations. They cancel out. I'm left with D equals 3.
3.
So now I have the
that explains that. Oh, I'm sorry, cut you off. No, that once you show it that way, yes. I definitely also, when I start seeing algebraic equations, I definitely start immediately panicking.
Yeah.
But now I see what you're saying about with the P0 made sense because it was 1 for 1, but now I see on this one about with it being 10 and then solving.
Yep,
Okay.
and that's why they gave you P sub 10 and P sub 8, because once you know those two numbers, you can plug into this equation and solve for D. Now I think we can write the explicit formula. Here's the explicit formula. P sub n equals P sub 0 plus D times n. Well, let's plug in. P sub 0 we know is 8.
Right.
D we just figured out is 3. And the n goes there. So in this answer box, you'd be putting an 8 in this box, a plus sign in this box, and then number 3 here. They already put the n for you, so you don't have to type that in.
And then so for number B, or letter B, it would then just be P50 equals 8 plus 3 times 50.
You got it. Exactly.
Okay.
Yep.
So 158. Got it. Okay.
And this, now that you have this explicit formula, you could calculate P sub 230 or P sub 88, right? Whatever the subscript is, you would just plug that in for n in the equation and you would have the answer.
Got it. Okay. Thank you.
All right, let's, I think there might be a few more similar to this. Let's see here. I think you had 13.
I would like to go through 13. This was one where I followed, I could follow once you wrote it out, but I don't see how, like right now, even just looking at it, I don't understand, like not having the other resources around me, I can't look at this and figure how to predict the percentage.
Right. So let's write out a few terms in the sequence. Maybe we can see a pattern. So it looks like they're telling us that in October, the unemployment rate was 8.9%. Then in November, 8.9 in October. In November, it went down to 8.7. And in December, it went down to 8.5. And in January, it went down to 8.3. All right, so I'm trying to look for a pattern here.
Okay, and so this definitely looks to me linear, and then I can see what, 0.2 drop?
Negative 0.2. Good. Yep. So to go from one number to the next, you subtract 0.2. Good. 0.2%, right? Because everything here is working in percent. All right. Let's try to write the formula for this. So P sub n equals P sub 0 plus D times n. Because if we can write this formula, we can figure out any unemployment rate, for any time period. All right, P sub 0 is the first term in the sequence. Well, that's 8.9%. So I'm going to call this guy P sub 0. So this is going to be 8.9%. D, we know, is negative 0.2. So here it is. This is a formula we can use to calculate the unemployment rate for any for any time period.
Okay.
All right, let's go to part A. It says predict the unemployment rate in January 2013. Let's see, these were 2012 numbers. So what I have to do,
This one,
go ahead.
I'm sorry there. This one, so it starts in October of 2011 and ends in January of 2012. So then would I use the 2011 timeline because of P sub 0, or would you go off of the latest number?
I'm sorry, this is 2011. I'm sorry, you're right. This is 2011. My mistake here. I should have written this as 2011. Yeah, these are 2011. I'm sorry, my mistake.
No worries. No, thank you.
All right, what I have to do now is, and let me write down the n. Remember, this is, we're calling this like n equals 0. This is n equal 1. This is n equal 2. This is n equal 3. What we need to figure out is for January 2013, what is n equal? If I could figure that out, I'd be able to plug in and figure out the unemployment rate. I'm sorry, this January here should be 2012.
Yes. Let's see. Can you hear me?
Yep. Yep.
Oh, all right. Yeah, my microphone just kicked over. Okay, so looking at that, if the last one is January 2012 to 13, 12 months, plus if that's already N3, so that'd be N15.
You got it. So n equal 15 is the month we want. So let me go plug in here. We want P sub 15. All right, that's going to be 8.9 plus negative 0.2 times 15. And now I can just work this out on my calculator. So this is going to be 8.9 plus negative plus negative 3, I think it is. So it looks like 8.6%.
Oh, gotcha.
I'm
Okay.
sorry. My mistake.
I have to do 15 times.
5.9%. Guess I need more coffee. You can work this out on a calculator.
Yeah, no, I see the concept though as well. Now that we do see that, even just when we wrote it out here before, I immediately start looking, and I don't know why I do this, but I start looking at ways to balance an algebraic formula that don't actually make sense. Like I'm looking over here going, okay, I need to divide both sides by 15, and then it is just as simple as negative 0.2 times 15, and then add 8.9 to it.
That's right. And I'm doing the multiplication first before the addition because that's what order of operation says to do. I wouldn't try to balance the equation here. Balancing the equation is only when you have like an unknown number, like an x in the equation that you're trying to solve. But on the right side of this equation, it's all numeric. So I could just work it out on a calculator.
That makes sense. Thank you.
How about part B? Part B says predict.
I'm sorry, go ahead.
No, I was just going to say, predict when the unemployment rate is 0. Any idea or thoughts on what you might do for that one? We just figured out, by the way, that in January 2013, the unemployment rate is 5.9%.
Mm-hmm. I mean, this is one of those where I can see there's a pattern, but I can't yet see how to utilize it.
Yeah. And so what we're figuring out here, this P sub n is the unemployment rate at some time period. P sub n. But they're telling us when is the unemployment rate going to be 0? So I'm going to replace P sub n with a 0. This is a little tricky, but what you're finding in this formula, this P sub n number that you're calculating, is the unemployment rate. In, in the context of this problem. And N, capital N, is really the month that you're interested in. As an example, let's go back to part A for a second.
Okay.
You wanted to know the unemployment rate for month 15, right? N equal 15. You replaced N with 15, you got the answer 5.9%. So that's the unemployment rate in month 15. But now part B of the question is saying, when is the unemployment rate going to drop all the way down to 0? Well, that's what P sub n represents, the unemployment rate. You're trying to find the month though. So we don't know capital N for this one. So I'm going to replace this P sub n with a 0. Now I have to try to solve this messy equation. Let me erase a little bit here so we could do it. Erase up here. All right, here's the equation we have.
Oh, so N is going to give us the number, and then we're just going to have to walk it up from what we determined P sub 0 initially was.
Exactly. Yep.
Okay.
So here's what we got. The equation is 0 equals 8.9 plus negative 0.2 times N. All right, well, I know my goal here is to get this capital N all by itself on the right-hand side of the equation. But I have this messy 8.9 sitting here. I want to get rid of that 8.9. I want to cancel out the addition of 8.9. Well, to cancel out an addition like this, we use the opposite, which is subtracting. So I'm going to subtract 8.9 from both sides of this equation. By the way, anytime you're solving an equation like this, whatever operation you do to one side, you have to do the same operation to the other side. All right, on the right side, 8.9 subtract 8.9 cancels out. On the left side of the equation, we have 0 subtract 8.9. Well, that's negative 8.9. And on the right side, we have negative 0.2 times N. One more step. I want to get N by itself. Well, right now, N is being multiplied by negative 0.2. If I want to get N by itself, I've got to get rid of or cancel out that multiplication. The way you cancel out a multiplication is to use division. So I'm going to divide both sides by negative 0. On the right side, multiplying and dividing by negative 0.2 cancels out. So that's going to leave me just N all by itself on the right side, which is what I want. On the left side, I have negative 8.9 divided by negative 0.2, and that looks like N is 44.5. Oh, that's weird. Why are they giving us a decimal year?
Okay, so that I could see that. Well, with the 0.5 then is going to be the number of months after the P sub 0 month.
Yeah, so I think we're gonna have to round this to 45 months.
Okay.
Because so I think we should round this to 45 months. All right, so what we got to do now is if October of 2011, if October of 2011 is N equals 0, we've got to figure out what month is 45 months ahead of that. So
okay.
I guess.
So 48 months would be October of 2015, and then
Good.
back it off 3 months from there.
Good way to do it.
Okay. So that would be the July of 2015. Okay.
And so part B was asking you to replace P sub n with a 0. That was the key to that part.
Gotcha. Okay. I've had problems with that in the past as well. It is like building the formula off of. Sometimes, like once I get geared in one direction, looking at it, being able to look at it from the other side instead of trying to solve for the piece of zero, solve for the other integer.
Yep. So this is an important formula to write down somewhere, because anytime you see a linear pattern mentioned, or if you can recognize it's linear, this is going to be the equation to use. And again, we call this the closed form version, because it allows you to figure out p sub n for any n that you're interested
And I've
in.
done that. I've written the equations next to each of the, whether I've got linear, exponential, or logistic. Of course, logistic has more equations, but
Yep. Good. All right. Let's see what else we got. I think you mentioned 14.
But I think now that we've done this one, I think I understand.
This is going to be very similar. And notice it says assuming a linear growth model. So when you see that, you know it's going to be the same formula we just used.
So I feel pretty comfortable with that one now, having just gone through 13.
Good. Let's look at 15. I think 15 is going to be very similar also. 15 is nice because they're actually giving you. Notice 15 says L sub n equals 66.17 plus 0.96n. So they're giving you this linear formula as part of the problem, which is nice. And they're telling us that n equals 0 corresponds to the year 1995. N equal 1 is 1996, and so on. All right, it says here, what is the life expectancy of a person born in 2012? Well, if I could figure out the corresponding n number for 2012, I would be able to just plug in that n into this formula.
And so on this one, I got the part A, it was the part B. But now looking at it, and I still don't have it, but I can try to work this one. So part B is just going to be the other way, right? Are we going to do, so we're looking for expectancy of 90. So would it be 90 equals 66.17 plus 0.96n?
You got it. Exactly right. Yeah, because this L sub n represents life expectancy. They kind of told me that in the problem. And so if they tell me the life expectancy is 90, they're asking me to replace L sub n with 90.
Okay. And then I can work that out after that, but then I'll subtract 66.17 from each side, and that'll
Good, that's
get
the first
me
step.
33 point something, 0.83, I think.
Yep.
And Larry, I'm on the other side of you. It's let's see, it's 10:40 at night, and I'm on the other side. Like I need coffee for too late.
Oh,
Let's
okay.
see.
Yeah, that's right. I forgot this is very
No,
late.
you're fine though. Please,
So
I'm
whenever,
a night owl, so I'm used to it.
by the way, we don't have to finish all of this today if you don't want. We can get together again on Thursday or something like that if you would prefer, because I don't want to.
No, I would rather if you don't mind and if you have the time, I would love to just do it now while I'm on a roll.
Let's keep going. And what do you think the last step
So,
would be then on this?
and then dividing by 0.96.
You got it. Very good. Very good. Yep. That's it.
And then I'd have to work that one out, but let me see if I've got something that'll function as a calculator right now.
Doing this, I'm coming up with n equals did you come up with a value of n here? Bob, I'm not hearing you. Maybe your volume is not working. Still not hearing you. Let me double check that my headphone is still plugged in. Yeah, I think it is. You can hear me, right?
How's that? Is that better?
Now you're back. Now you're back. Good.
All right. Sorry about that.
No, that's
As
okay.
soon as I went to my calculator, it kicked off.
Okay.
Okay. So I divided 33.83. I divided 33.83 by 0.96.
Bob, I think it should be 23.83. Double check. It was 90, subtract 66.17.
Oh. Yes. Okay. That would be why. Perfect. So 23.83 divided by 0.96 gives me 24.82. So 25.
I think we should round to 25. Exactly. Yep. And
So
now
1995 going back to the problem is P sub 0. So that would be the first one year. So you would add 25 to 1995. 15. So that would be 20, the year 2020.
I think that sounds right.
Yes. Awesome. Okay.
Good.
Perfect. Yeah, that makes much. That was the thing is I think a couple more of these might be like this, which would be great. It's, if you got 3 of the same theory of operations on a problem, and then you don't know how to do that theory of operations, you're down 5 questions.
Yep.
Okay, perfect. Awesome.
All right. So, what was the next one?
So the next one is question 17, and this is another one where I followed your I followed your sheet, but I didn't understand. Like again, had the second I remove your guide and I try to do it again, I'm not grasping the concept.
Okay. So the big difference about this question is it says exponential growth. And exponential growth, the word exponential means grows very quickly.
Mm-hmm.
And so here's the formula to use. P sub n equals P sub 0 times R to the exponent n. In R, growth rate, sometimes it's I think that's right, growth rate. And so what we want to figure out here, part A says, what is capital R?
Mm-hmm.
And notice they're giving us P sub 0 and P sub 1. So let's go ahead and plug into the formula, and maybe that will help us figure out R. All right. So I'm going to write this formula as I'm going to write the formula for P sub 1. So I'm
Okay.
replacing n with a 1. So P sub 1 equals P sub 0 times R to the exponent 1. So what I did here is I just let capital N be 1. The reason I did that is they told us P sub 1 is equal to 12. Now, I think this equation we can solve for R because R is going to be the only unknown quantity. P sub 1 we know is 12. P sub 0 we know is 8. And that's R to the 1. Well, R to the 1 is really just R. Right? R to the exponent 1, you could just write it as R. Well, now I can solve for R. I'm going to divide both sides of this equation by...
let's see. You're going to divide both sides by 8.
Good. And so R is just 12 over 8, which I think is 1.5. Yeah,
1.5. This, I was realizing as you were discussing, this goes back to what you had talked about in the beginning about finding the explicit formula.
Yeah.
Now that I see the explicit, now that I know how to find the explicit formula and I see it here, everything else makes sense.
Yeah. So
in
why don't we go
finding
to
that, you found R and you found A and C, and then like you said, you can plug in when it asks for P sub 9 or P sub 80 or P sub whatever, you just plug in that integer number with this formula.
You got it.
Okay.
So let's write the explicit formula just to be just to finish this up. Well, P
Sure.
sub n equals, this first box is the P sub 0 number. For us, it's 8 times R to the n, but R is 1.5. So this is going to be 1.5 to the n.
1.5 to the n power. Okay. Perfect.
And then when they ask you for P sub 9, that's just replacing n with 9.
It's just going to be 9 equals 8 times 1.5 to the 9th power.
Yep. And you can work that out on your calculator because you have an exponent button.
Perfect. Okay. Let's see. Number 18. So this one, I understood the formula when it talks about part A. I'm finding I think the P 1 and 2. I think, let me look this one because I didn't get B, but I think this was again where I didn't understand the explicit formula.
Yeah.
So this would be Pn. Let me just write it here. Pn equals 4 times Pn minus 1. All right. And then the initial is P sub 0 is 5. So it's going to be, let's see. So it's going to be 5 equals 4 times Pn minus, will you just write equals 4 times Pn minus 1?
Well, for the explicit formula, you have to write it in this kind of format right here. If you can see my screen, P sub n equals P sub 0 times R to the n. That's the format we want to write it in. We need to fill in P sub 0, and we need to fill in R.
Oh, you're doing that. Okay, I got you. So
P sub 0, and by the way, R is what each term is being multiplied by to get the next term. And if you were to fill in, let's do part A here for a second. Did you do part A yet?
I see it in here, but I think I was going off your notes. So I'd be more than happy to go through part A again.
Let's do part A. So here we can use, they're giving us this recursive formula. And they're saying P sub n equals 4 times P sub n minus 1. They want us to figure out P sub 1. Well, P sub 1 is 4 times P sub 0.
Oh, okay.
But they gave us P sub 0 as 5. So P sub 1 is 4 times 5, it's 20. Let's do P sub 2. P sub 2 is going to be 4 times P sub 1.
Which would be 20. Okay,
4 is
so
4 times
80.
20. Yep. And that is
80.
80.
And then P3, it was going to be the same. It's going to be 4 times 80, which is 320.
Good.
Okay, I
Now
see that part now.
Yep. So I can kind of get a sense of R. R is what number do you multiply to get from one term to the next? Well, I could see R is 4.
Okay.
And I can also see that from the recursive definition. Because if you look at the recursive formula, to get the next term, P sub n, you take 4 times the previous term. So here's the explicit formula. P sub 0 is 5. That was given to us.
Mm-hmm.
R is 4. We could see that from the recursive formula. So P sub n is just 5 times 4 to the n.
So when you see these problems, when it talks about like population growth or whatever, and it gives you with the recursive rule, whatever that formula is, first thing you have to do is you have to when I see recursive, I should think linear.
No, recursive is not linear necessarily. Recursive is just a way. You could have a linear, you could have an exponential. A recursive is just a way to generate the next term in the sequence using the previous term. So let's say they asked you to find P sub 50 on this one.
Okay.
If you were going to use the recursive formula for P sub 50, you would first have to know P sub 49. But before you can know P49, you would have to know P48. But in order to find P48, you would need to know P47.
We use the exponential formula to find R, right?
Yes,
So
right.
how,
R,
how do we know that? I mean, when I see population growth, I'm going to assume exponential. Is that the only way? Or is there other ways to infer that this was an exponential?
the other way to notice this was exponential is the recursive rule itself.
Okay.
A linear pattern is when you're adding numbers. An exponential is when you're multiplying. And in this example, we're multiplying each term by 4 to get the next term.
Okay, that makes sense. So then
The other way I can notice it's an exponential is when you look at the template they're giving you for part B. Do you notice there's an n sitting in the exponent there?
Okay.
That's why they call it an exponential formula, because n is sitting up in the exponent.
Okay. That makes sense. So when I see that, so first you're going to solve for, well, let's see, we already had P0. So we can find n, you're going to solve, or we're going to know n, you're going to solve for R. So
We need to
first we
figure out.
solved for R.
Yep.
And then we turned around after that and we were able to work it each question at a time, P1, P2, P3. And then that also revealed the explicit formula. Okay.
And then part C says, how many generations will it take to reach 1 million? This one's a little tricky. Well, that's what this P sub n is giving you. P sub n is like the population at any time n. So let me write it. Here's our formula. P sub n equals 5 times 4 to the n. Well, they want to know, when is this population going to reach 1 million? So they're asking, if P sub n is 1 million, what would be the value of n? So part C is asking you to replace P sub n
Okay.
with a million. This is similar to the unemployment rate example, right?
Mm-hmm.
Where they said, when is the unemployment rate 0? We replaced P sub n with 0 there, but now they're asking, when is the population going to hit a million? All right,
I'll be honest, on this one to solve, I kind of on this one I went and I saw, okay, 3 is already 320. I can see it's growing exponentially, and I kind of threw a couple numbers until I got to.
that's exactly a good way to do it. Yeah.
Okay.
One way you could do it is in this equation, I could start off dividing both sides by 5, because that would just get rid of that 5 in front.
Okay.
And then that would be 200,000 equals 4 to the n. And now the best way is just kind of guessing. Take some different values of n, experiment, plug them in, and see when will you get to 200,000 or greater. And so I could just try some experiments here. I'm going to do it on my calculator quickly. I'm going to use n equal 10 as just a starting point. I'm just making that up.
Sure.
4 to the exponent 10 on my calculator is a little too big, because 4 to the exponent 10 is like over a million. So I'm going to try 4 to the exponent 9. 4 to the exponent 9 is about 262,000. I'm going to try 4 to the exponent 8. 4 to the exponent 8 is too small. 4 to the exponent 9 does it. It gets me above this number 200,000. So I'm going to use n equal 9. So doing experimenting here is perfectly okay. It makes sense.
I like your way though better, because your way targets when you already removed a lot of guessing work on that one. Like I didn't even break it down as far as you did with getting to, to the 20,000. I
Yeah.
put the whole equation out, and I was just like, let's see what totals a million.
And that's okay too. You could do it that way. It might take you just a little longer, but that's not a big deal. So your way is perfectly fine as well.
All right. Well, thank you.
All right. So this was a good example of this exponential kind of growth. Let's see what else.
19 again. I think, and I got that one. I think that was just that I can see that's a rehash of 18.
Yeah. And 19 is, I think, even a little easier, because
Yeah.
when you go to write the explicit formula, remember the explicit formula is P sub 0 times r to the exponent n. Well, they're giving you P sub 0.
Right.
And they're giving you r. So that makes it easy to write the explicit formula. And then you can answer the other questions.
Mm-hmm. Yeah, and that's what I did again with. Yep, that one at least I was tracking. Got it. Substitute n's for 5s for P5, and then again just more trial and error, getting to 10 generations to fall below 200.
Got it. Good. Yep. Excellent. All right. Let's see here.
Yeah, number 20 I still don't get, but maybe that has been cleared up now.
Okay, so there's a couple of questions that just ask you for a growth rate. And this is really a kind of a simple formula to find a growth rate. Let me give you an example. Let's say your salary goes up this year.
Okay.
And you want to know, what is the growth rate of my new salary? Like, what percentage increase did I get in my salary? If you wanted to find a percentage increase, and again, this is kind of similar to a growth rate, the way you would do it is you would take your new salary, subtract your old salary, and divide it by your old salary.
This is for percentage increase growth.
Growth rate. Yeah, growth rate. Let me write the growth rate formula down here on the bottom. If you want to know the growth rate, you take the new value minus the old value, divided by the old value. And then usually we multiply by 100% because usually we want to convert this into a percentage.
Divide by the value.
So I'm going to write down the data they gave us in this problem. In 2008, they said there were 44 cases. In 2009, they said there were 73 cases. The 2008, I'm thinking is the old number. And the 2009, I'm thinking of as the new number, the 73. I'm sorry. And again, try to use this in your as an example of something you can relate to. Again, I think salaries. Let's say you want to know the percentage increase of your salary this year. You would take your new salary minus your old salary, because that would tell you how much did your salary go up this year. Let's say it went up $5,000. That's the top of the fraction. If you take 5,000 and divide it by your overall salary, let's say 50,000 is your old salary. 5,000 divided by 50,000, that tells you just got a 10% increase in your salary.
Okay.
So anyway, let's use this formula down here on the bottom. This is in the textbook also for growth rate.
Let's see. So if I'm doing, so it's going to be, what do we got here? What did I just write? So it's new minus old. So 73 minus 44, I got 29. Over old, which is, what did I say it was? 44.
You got it. Good. Yep.
29 divided by 44 is, do you round to two decimal places?
Let's see. The problem says round to one decimal place.
Okay. So 0.7.
Well, here's what I got. I'm getting 0.659 time 0.6591.
Oh, I'm sorry. When I was asking for that initial one, would you round that? How many places would you write that initial? Like the 29 divided by 44. It's the same. I got the 0.6590 yada yada.
I'm gonna write this out to many decimal places to start with.
Okay.
So let's write it out to like 5 decimal places, let's say, to start with.
Gotcha. Okay.
Because I'm going to round at the very end, according to what the problem tells me. But I'm not ready to round yet. So let me just write out, I'm getting 0.65909 times 100%. Because we want to change this into a percentage.
Okay.
How do you know you want to change it to a percentage? Well, when I look at the answer box, do you notice there's a percent symbol? So I got to change this to a percentage. To do that, you move the decimal point 2 places to the right. So it's going to be 65.909 percentage. Now let's round our answer to the instructions. The problem says round your answer in a percentage form to 1 decimal place.
Gotcha. So it's just going to be 65.9%.
You got it. That's it.
And then I remember you had talked about it being negative in here.
Well, it would be negative only if the new number, because I got to ask myself, did this growth go up or go down? Well, I went in 2008 from 44 to 73. So that was an increase.
Okay.
Well, an increase implies a positive growth rate. If the number of flu cases had gone down, let's say instead of 73, it was 33, let's say.
Gotcha.
Then that would be a negative growth rate because the number of flu cases went down. They decreased.
So it's either going to be a negative growth rate or you're going to say 65.9% decrease.
Yeah, and I think there's an example where you'll enter a negative number.
Okay.
But you don't have to worry about that because the formula is going to give you a negative answer if that's the case.
Okay.
So you can just let the formula do its thing and it will give you the correct positive or negative value.
Got it. That makes sense.
All right, let's see here. I think you said 20. Well, I think 21 might be very similar to this.
Okay. Do you mind if I'm going to try this one then real quick?
Yeah.
Oh, go ahead.
No, I was just going to say, this one might be an example of a negative growth rate, but just plug into the formula and see what you come up with.
2010 and 2011. Okay, so this is so we're going to take the new 17,389 minus the old 19,753 divided by the old 19,753 times 100%. All right, so let's see. Okay, so on the top I have negative 2,364 divided by, I'm sorry?
No, I said good. Good work. Yeah.
Oh. Divided by 19,753, which gives me negative 0.11967. Which times 100 moving over gives me a negative 11.967. It says round to 2. So negative 11.97.
You got it. Excellent.
Awesome. Cool. Okay. I see what you mean as well. Yeah, where it has. That's another one where I'm now that I see the formula, I can see where the formula works out. Exactly like you said, it makes sense. It's going to be a negative. It's going to be a decrease, a negative percentage because it is a decrease from the old year to the new year.
That's right. The enrollment went down, so it makes sense that it's a negative growth.
And I'm glad now that we're seeing these. I like those ways. Math is one of those. There's some parts of math I'm really good at. Like when I used to do trig a lot, and I was good at that. I like building those gates to check yourself. I hate getting 20 minutes into a math problem and realizing I'm totally off and have no idea where.
Yep.
All right. Awesome. Okay. Let's see. I got 3 more if you don't mind.
Okay.
I got 22. The geometric sequence. So this is going to be the same that we talked before, right? With Pn equals P sub 0 times R to the nth value.
Yes. But
okay,
this question is going to ask you to sum up. Well, let's do the common ratio first. Let's do part A.
Okay.
When you think about the common ratio, what it's asking you is what number is multiplied to get from one term to the other. So let me look at this. It's 4, then 12, then 36. What would you multiply 4 by to get 12?
3.
3. What would you multiply 12 by to get 36? 3.
Got it. Same 3. Okay.
So the common ratio R is 3.
Okay. Got it.
All right. Now, what I could do here, so they're going to ask me to find the sum of P0 to P10. I could either do this manually, or I could try to look for a shortcut form.
Is
By the
this,
way,
is
Bob,
this when you use a radical?
There's a certain formula for a geometric sum that we can talk about. Bob,
Okay.
are you an Excel user?
Ooh, I am. I am not good with the formulas.
Okay. All right. I was going to say you could use Excel for this, but here's what we could do. P sub 0 is 4. That was given to us. P sub 1 is 12. That was given to us. P sub 2 is 36. That was given to us. What would you guess P sub 3 is going to be?
Let's see. 36 times 3, which is 108.
Good. And you could keep going in the same
Mhm.
way to get to P sub 10. And then you can add up these values. That would be the long way to do it.
Okay.
Turns out there's a shortcut formula. To find the sum of a geometric sequence. Geometric just means each number is getting multiplied by 3 like this. It's a messy formula. It says if you want to add up P sub 0 plus P sub 1 plus all the way up to P sub, I think it's P
sub 10.
P sub 10. Here's the formula to use. It's R to the n subtract 1 times P sub 0 divided by R minus 1. Let me point this out to you, Bob, in the book, because this is a kind of a messy formula, but let me find it for you real quick in chapter 9. And this formula is a little tricky to use. This is on the bottom of page 275.
275, okay.
All right. Now, I know in our example, R is 3. We figured that out. So we know R. We know P sub 0. P sub 0 was given as 4. So we know P sub 0. The only thing we have to figure out is N. Now, you might think N is 10 here, but it's not. Here's what you got to recognize on this sequence. Do you notice we're starting at a 0, starting with P sub 0? And we're going up to P sub 10.
Oh, so it's going to be 11.
N is 11 in this example. Yeah, because when you start counting at 0, that's like an extra number, an extra count. So we're going to have to plug in n equal 11 in this formula. So now we can plug into the form. All right, so for us, it's going to be R to the 11. Let's plug in. I guess we could plug in the numbers. Let me do that. Let me erase some of this here just to get a little more room.
So it's going to be 3 to the 11th minus 1 times 4 equals 3 minus 1, so 2.
You got it. And this is a job for your calculator.
Definitely. Let's see. Okay, minus 1 times 4. Okay, so on the top I have, let's see, 708,584. Okay, divided by 2. So I have 354,292.
I think that sounds right. Good.
Let me see. That's it. Thank you. Okay.
Good.
Awesome.
That
So
answer
now I don't have to go all the way to 10.
Right. That answer you just got would be the same answer if you added up individually. P sub 0 plus P sub, but this, of course, is a lot quicker.
All right, so we got that one. So 23.
All right, 23. 23 is a new model. It's called logistic.
Mhm.
And logistic is something where a quantity is growing, but it might reach a capacity. Let me give you an example. The number of fish in a pond.
Okay.
The number of fish will keep growing and growing, but it won't grow continuously because the pond only has a certain amount of room for the fish to grow. It only has a certain amount of food. So the number of fish will kind of peak out at some value called the capacity. So that's what this growth model is about.
Okay.
This would also be for like, let's say the population of wolves in Yellowstone National Park. The population of wolves can't keep growing and growing without bound because there's only a certain amount of prey and things like that. So there's a kind of a capacity limit. So for this, you want a formula from the textbook. Here's what the formula looks like. P sub n plus 1 equals R times P sub n times 1 minus P sub n. And they kind of use this in a weird kind of notation where they use P sub n plus 1, but that's okay.
Let me make sure. Let me rewrite this because I think I wrote it. Not that I don't think it would have worked anyways, but okay. So
and let me give you the page number on this. This is on page 279, like in the middle of the page.
yeah, because I found there were three. I got the proportion of population formula, the population formula, and this is the fraction of carry capacity.
No, this is the way you figure out the population at any time. So this is like the way to figure out the population. And this is kind of like a recursive formula.
N plus 1.
And
okay.
so let's do P sub 1 maybe. All right. Well, if I want to write P sub 1, P sub 1 can be written using P sub 0. So this is going to be R times P sub 0, 1 minus P sub 0. Does that make sense? Because if you look at the formula that I started with, and you let capital N equal 0,
let's see. PN. Okay. Yep. I'm tracking. And then you just fill in the 0.3 for
R,
P sub 0.
yep, R is 0.8 in this example. P sub 0 is 0.3. And this parenthesis is going to be 1 minus 0.3.
Okay. So then I've got, let's see. So 0.8 times 0.3 is 0.24 times, let's see, 1 minus 0.3, which is going to be what, negative or 0.7? No. Yeah?
Yep.
Okay. So then 0.7 times 0.24 is, I got 0.168. So P1 is going to be 0.168.
Yep.
All right. And then P2, you're just going to repeat.
Yeah. So P2 is R times P sub 1, 1 minus P sub 1.
0.8 times 0.168. And then times 1 minus 0.168. So I'll do that. 0.8 times 0.168 is 0.1344. And then inside parentheses, 1 minus 0.168 is 0.832 times 0.1344. So the answer, so P sub 1, or excuse me, P sub 2 is going to be 0.1118.
I think that sounds right.
Okay, perfect. And now this talks about figuring out what percent of the habitat's carrying capacity is taken up by the third generation.
And really, that's another way to ask you to find P sub 3. When they say the third generation P sub 3. So what's happening here? You know, if you remember, P sub 0 started out at 0.3. That's the initial population of this. Let's think of this as like fish in a pond. So the initial population is 0.3. Whatever that, maybe that's 0.3 thousand or something like that, whatever that represents.
Sure.
In year 1, P sub 1 went to 0.168. That means the population went down. P sub 2 is 0.118. That population went down. So this is showing us that the population in this pond or whatever is decreasing. The only thing about part C is you need to put your answer in as a percentage format.
I was going to ask, so this is kind of like that other one where you just move the decimal right 2 places?
That's it. Yep.
Okay. If you don't mind, I'm just going to knock this out real quick then. 0.8 times 0.1118 is 0.08944. All right, and then for inside the parentheses, it's 1 minus 0.1118 is 0.8882. And then I would do that, multiply that by the 0.08944. Gives me 0.07944. So if we move that over, it's gonna be, let's see. Oh, I did that twice. Okay, so it's gonna be 7.94%. Got it. Okay. So that one I also, I'll admit, I got confused in looking at. I think is that also on page 2? Was it 275?
Yeah,
I think
279.
279. It talks about the logistic growth model formulas, and it gives me like 3 or 4 different formulas in there.
Yeah, if you look in that red box,
okay,
the logistic equation in that red box is the formula we just used.
Gotcha. That one, I think what happened is I saw carry capacity, and so I went to the carry capacity formula. Oh wait, that is one we just used. Okay. Perfect. All right, but that makes sense. That makes so much more sense now.
Okay. And I think 24 is going to be very similar to what we just did. Because for 24, again, I'm going to write down the formula that says P sub n plus 1 is equal to R times P sub n 1 minus P sub n.
And this was another one where I followed, I think I kind of followed, or you had answers on there, but I was just not tracking, but I can see now where that is. Now that I'm using that formula. So R here is still 0.8 and P sub 0 is now 0.2.
Yep.
Okay.
So for P sub 1, it's just going to be, I'm sure you can work this out. R is 0.8.
Yep.
P0 is 0.2, and then 1 minus 0.2.
And then 1 minus 0.2.
P1, I think I'm getting 0.128. Bob, I'll be back in 1 second. I'm going to take care of my dogs here. All right. Sorry about that, Bob. Did this one work out okay? Bob, I think your microphone cut out again.
How's that?
Now you're back. Yes.
Sorry, every time I kick my phone over, it kicks the mic onto something else.
Okay.
I did. I figured out my issue, and now I'm getting the 0.128, and let's see what we just on. 0.128, yes. Now I can
Okay.
see, and then from there I can figure the P2, P3, P4.
Right. Once you know P1, that will let you figure out P2 and so on. So that's what this recursive formula is all about.
I think that's it. I'm going to work through the first couple when we were completing out. But I really appreciate that. I'm gonna hold these notes back. I adjusted my formulas here, but a lot of that stuff definitely makes a bunch more sense now.
Okay. And I'll send you this recording in case you want to go back and look over any portions.
Oh, that would be awesome. Thank you.
All right.
Larry, thank you again so much. I
Yeah.
really appreciate taking your time.
Thank you. Thank you for hanging in there. And I hope you get to sleep soon.
Oh, definitely.
All right.
Thank
All
you.
right.
You have a good night or
You too.
day.
Take care. You take care.